nothing changes at all. If it's more terms on the bottom, nothing changes. So if I'm going to do this here, right? So what times what is x squared times what is x cubed? So x times x squared is x cubed. X times negative 4x is minus 4x squared. X times 3 is plus 3x. I mean, do you understand? Nothing changes. There's nothing to consider. Not a damn thing changes. Nothing changes. Just like with normal long division, if I have a bigger number out front, does that actually change any of the process? Nope. Just more shit to consider. I just got more stuff to write, but it comes from exactly the same place. Is that cool? Yeah. And then you just put these together. You change the signs. And then you got 10x squared minus 8x, and then you bring down the plus 1. And then, yeah, you just keep on. Is that all right? So here, for example, if this was a slant asymptote, that would be my slant asymptote, because whatever the remainder is would go to 0. If I let x get big, yeah, okay. I like it. And again, as a student, you guys tend to focus very much on the things you couldn't quite get. And you forget all the stuff that you were able to do, right? And you're like, none of that matters or shit, Jeff, if it ends up being a D or whatever. But yeah, you can make corrections. The fact that this stuff is not on, so for example, normally a quiz, if you make corrections, it could go up again if you do better on the next test. But y'all remember this stuff will not be on the next test, right? So I'll kind of do that thing with the final. So if you do better on the final than you do on this quiz, then I can bring this quiz's grade up. Does it make sense? Yes?
I don't feel like the last question is very time consuming.
Yep.
So for the test, is there do you want us to do it first?
Not necessarily. So I gave you one that worked. There's another nice whole number that worked. And here's the thing that I talked about in office hours. If I divide something that was it started off as x to the 4th, are you with me? And it's blah, 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 blah. And I get this, I get 5, negative 4, 5, negative 4, 0, right? What does this mean?
5x cubed, 5x, or negative 4x squared, plus 5x minus 4.
Do I need synthetic division anymore?
No.
No, so that happened on that problem. If you got two things to work, and I gave you one, and if you got another one to work, you ended up with a cubic that you could do what to? Group, yeah. So in general, why do we use synthetic? The only time I really have to use synthetic is when what I'm working with I can't factor it like normal. So that's why we definitely always can stop using synthetic when we get to squared. Because either I can factor that or I can quadratic formula that. Are you with me? I never have to do quadratic past the square. Ever. And some cubes, I can stop at. So we'll see if anybody noticed that. Okay.
So you can't stop at the degrees 4?
Because there's no,
Yeah.
well, I don't want to be too general because there could be some very specific ones, but we don't have any process for 5 terms that'll always reliably work. Does that make sense? 4 terms, we got grouping, yes. 5 terms, a type of grouping might work good, but it gets weird. Yeah.
After we got so you know how you gave us one value and then we found the other value, do we use the bottom to then find the third answer?
Yeah, see, if I got this, I would just group and keep going, right? So you should have ended up with 2 complex solutions and, I can't remember now, 3 real solutions, yeah. So we'll see, again, guys, you just show me what you know you're trying to do. If you don't quite get there on a problem like that, that's not the end of the world, because you make one little mistake and you won't even know that's the right answer because you did a little negative mistake or something. That's just a human thing. So I'm not gonna That's why you got to show me your work, because then it can go, oh, you just made that negative. Otherwise, you would have gotten the answer. You would have been able to do this. I see you know what you're trying to do. I'm going to give you most of the points. Does that make sense? Okay. Because a lot of you guys, okay. Just a couple things. If any of you ever have anything happening in your life that is taking time away from homework, you're not able to get ready for stuff, whatever, correct? You never have to give me more details than you want to. Just let me know, and we'll work on keeping you up to date. We'll work on cutting the homework down so you can catch up. Does that make sense? And also, if you just need a mental health day or whatever, you can just send me an email and say, Jeff, I'm not even gonna lie, I just need a day. And I'm like, all right, watch the video later. You guys with me? Because again, I mean, have you guys noticed this? Pre-calculus is what I call a dense class. Do you feel like we've done an insane amount of stuff?
Yes.
And it's not even the halfway point yet?
Yes.
Okay. Pre-calculus, especially 176, because do you guys know what 176 is? It's 170 plus 175. Smack together, right? And that's normally 4 units, 3 units, and then we smacked it, we made it 6 units. You guys kind of with me? All right. So I understand. Pre-calculus is a lot. It just is. And that's why I try to get you ready. That's why I told you about tutoring. I got all these kind of office hours, right? So again, if you're somebody who's not where you want to be, and there are identifiable things you are not doing, start doing those things. It's not too late. Okay. So going forward, real quick, if there's old homework you haven't finished yet, in general, your main priority is new stuff. So for example, today's quiz, 5, 5, 5, 6, 5, 7. If I were you and I had all this other homework, I would have dropped everything and just focused on 5, 5, 5, 6, 5, 7. Get ready for this damn quiz. Next test is going to be on chapter 6. If you got chapter 3 homework you haven't finished, let go of that shit. Chapter 6. You get some time, chapter 3, chapter 6. You get some time, a little chapter, chapter 6, right? You guys kind of with me? Because in a perfect world, I would make homework worth nothing. I did that once, and everybody died on the first test. Not literally, thankfully. Everybody's test was shit because they're human. They're not going to do the homework for the class where the guy's like, let me try something out. The homework's not due. You guys just do whatever you need to. So what did they do? They did all the homework for the other classes that were due, and then nobody did any homework for my class. So everybody just died. And I went, okay, never again. So I have to make homework worth something to make you do it so you get the practice you need. But then what I end up doing is I'll get people that are like doing every problem and trying to, and which is what I want, but you have a lot of shit going on in your life, and you can't, and then you don't have and I've told you about this before, you have whole sections you didn't do, and then the test comes and smacks you in the face. And that's where I said, make homework your own. I have my shit that I said I want, and you go, it's nice you have desires, Jeff. Here's what I was able to do, buddy, right? I don't know if you guys understand that. Every class you do that. The teacher's not going to be like, oh, it's all good. No, it's going to be, finish this shit. What the hell? And you're like, great, good for you. Right? You guys kind of with me? Nobody told me that shit, but that's what I did because I had to. I think I told you my little sob story about walking uphill both ways to my 3 jobs. The 3 jobs is real. The uphill both ways is not. Right? That's the, you with me? I'm sorry. I'll stop. So I get a general sense of despair from some of you guys. And I know some of that is not because of me. I know we all have lives, we all have shit happening. I can totally relate. Trust me. But if any of it's affecting your job in here, your stuff in here, just let me know. You don't have to tell me details. Just say, I have a lot happening right now. Can you help me? I will. It's crazy. Okay. I'll stop. Yes?
So what part on chapter unit 6, or are we on?
Yeah, we're in 6. I'm so bad at, I just know ideas. I'm so bad at knowing what section the idea is in. We did, yeah, 6.3, 6.4, And we're doing 6-5. Yeah. I like it. Yes.
I was just confused. So when you're doing, when you have like your two vertex, vertical asymptotes, can you use a point inside the part, you know, like?
Totally, yeah. So if you have 2 vertical asymptotes, how many regions did you break it up into? 3. So if you have no information in one of them, you're going to want to use a point. So there was one region that you guys had no information. There's no x-intercept, so you want to plug that in, see where it is. Yeah. So I said at most 3 points, but to be honest, you should have only needed 1 or 2. But I said at most 3 just in case, because, you know, if I'm a student, I want to plug something in just to see if I'm actually going in the right direction. Okay. All right, so we're going to do a couple little things because I only got that much time. So what we did last time was I proved this property of logarithms. I'm going to use different letters just because. And again, what is a log?
It's the inverse of an exponential.
I love it. What is the answer to a log question always?
The power.
The power. Kick ass. What's the base that both of these have?
10.
No.
No, B.
B. So I'm multiplying 2 things with the same base. What do I do with the powers when I multiply 2 things with the same base? Add the powers. Do you guys see that? That's so awesome. So you don't have to rememorize shit. You already know all the properties of logs. Logs are powers. So what are the properties of logs? Properties of powers. So what do you do when you divide 2 things with the same base? You subtract the powers. Crap. Subtract the powers, that'd be 7. You guys kind of with me? It's a nice analogy there. Multiplication of inside of a log becomes the sum of 2 logs. The log of a quotient becomes the difference of 2 logs. Now, real quick, the most important property. The most important property is the third one, and it kind of builds off the first one. Actually, here, let's do a concrete example. You guys still have calculators, right? Yes. Can somebody do log base 10? What do you want to say, Jeff? Of 12 minus log base 10. And by the way, that shouldn't be doing that. I'm past that. Log of 12 minus log of 3. Sure. Try to put that in your calculator. Be careful. I think does it open a parenthesis when you put log in?
Yeah.
I hate this. It's like Microsoft Word saying, do you need some help? Shut up. hate that.
0.602059991.
Is that what you guys got? 0.60 blah, blah, blah? Okay. All right, I'll trust you. This property, see, math doesn't give a shit, right? You guys can be jealous if you want to, but math goes both ways. If I have a difference of 2 logs, how can I rewrite this using the property this way? Log of something minus log of something is log of the quotient. 12 over 3 is
Log
4. Now do log 4. Same damn thing. Cool. I like it. So there's a concrete application of the idea. Now, real quick, we are in the stage of just learning how this shit works. At the moment, you have no idea why it's good to know this. Correct? I understand in some of your guys' brains, I'm sure you're sitting there going, why the shit do I need to know this? We're just learning how things work right now. We're going to start solving equations, and then we have to know how all this shit works. Yes?
So when you're subtracting log, so log of 12 minus log of 3 is log of 4.
Totally.
is 12 divided.
Yeah, log there, that means log base 10. Right?
Totally.
Ah.
Good. Just like this symbol means the second root, right? Don't put a 2 there because it's the most used root. So what about this? Watch this, guys. Does anyone know what log, you could do it, Jeff. You could do it, buddy. There you go. Log base 12 of 3 plus log base 12 of 4. Does anyone know what log base 12 of 3 is? Can you guys do that? What would it represent?
Fraction.
What would it represent?
Power.
The power that 12 needs to become 3. Does anybody just happen to know that?
No.
How about this one? Is that better? No, but can I use the first property? That becomes log base 12 of? 12, yeah. I add powers when I multiply this shit, yes? And what's log base 12 of 12? Freaking 1. So I started with something I couldn't do shit with, used a property, easy as shit. You with me? Okay, so there's like a sort of immediate nice thing about knowing the properties, okay. Now, last thing we'll do today because I've got that much time. So we got this?
Yeah.
Yes?
Is this the third, like, principle?
Yes, good. What we're about to do is the third property.
Oh, we haven't done this.
I want to investigate log base b of m to the p.
Oh, wait.
And I want to use the first property to help me. What is m to the p? What does that mean?
Log.
No. What's just m to the p? What's m squared mean?
To the power
M
of
times m. So what's m to the p mean?
M
M times
times
m times m. How many times? P times. Oh, the good old days, the p times. All right. You guys semi with me? So if it was squared, I put mm. If it was cubed, I put mmm. So here I just got it, I don't know, p times. Right? You guys with me? What do I do every time I see log of, like, just this piece, m times m? How can I rewrite just that piece?
M squared.
No, I mean, how can I rewrite it using property 1?
Oh,
When I multiply things inside, it becomes
Addition.
addition. So wouldn't that be log bm plus log bm and just keep going? How many of these will I have?
P.
Everybody with me? You'll have p of those. So if I had 3 of them, how could you condense it? If I had 1, 2, 3 of them, how can you write it? No, come on. No.
M to the third.
How many log base b of m's do I have? 3. So what's x plus x plus x? 3x. So what's log baby m? Log baby m? Sure. Log base bm, log base bm, log base bm. What's that? 3 log. So how many do I have? P of them, yes?
Oh,
So
the
you get-
P log of M.
You
Okay.
get
Yeah,
log.
okay.
So watch this, okay. Again, if I just had 2 of them in there, isn't that log base b of m plus log base b of m? Isn't that 2 log base b of m? But how many do I have? P. So that would be p log base b of m. Just when I combine like terms, I get p of them, yes? 2 of them, 3 of them, 4 of them, p of them. Now watch this shit. All this shit in the middle is just an explanation of the shortcut. What's it look like happened?
The P just moved over to the
Power comes down. Maybe? You guys see
And
that?
that's only on opposite base? Wait, cause when you have like, if you have log base b of m to the b, then it cancels.
No. If you have log base b of b to the m, these cancel. Yep. You have log base b of m to the b. I know this is getting crazy. That can come down, but that's not really useful. All right, real quick. Last thing. I'm overtime now. I'm sorry. If I wanted to solve this equation, look what I could do. There's only one function that can save our variable. Where's our variable? Where's it stuck? In the power. The only thing we know where a power can be brought down, because that sucks. If I have 1 over x, that sucks. I need to get that up out of the denominator, correct? And I can just multiply. Here it's stuck here, so the only thing I can do is take log of both sides. Because then what happens? And then how do you solve?
Divide by 3.
And that shit you can put in your calculator, correct?
Okay.
So that's the next thing we're going to be doing is solving, solving exponential and logarithmic equations. It just never ends. Sorry, okay. All right, guys. I'll give this handout next time. It's got all the rules and some practice, but we'll do that next time. Yeah, thank you. Don't forget your stuff. I'm sorry. Stuff. Okay.